derivative measures the instantaneous slope, or the slope at any specific point. I made a 1.4-mile path around our Florissant Valley campus. And you can see as we run around that path, sometimes we're going uphill, sometimes we're going downhill. When I'm going downhill, my slope is negative. And the derivative would thus be negative because the derivative is measuring your slope. When I'm going uphill, my slope is positive. And so the derivative of the path would be positive because the derivative is measuring the slope. And at every single point, it's changing. When I get to the top of a hill, at that moment, I'm not going up or down. And so the derivative, which again is the slope, is not positive nor negative. It's zero. So just for the moment at the top of the hill, the derivative is zero. So notice now I'm going downhill. So my derivative, which again is measuring the slope, is negative. It's tapering off. I've hit the bottom of a valley. I'm not going up or down. And so the derivative is temporarily zero because I'm not going up or down. It's not positive or negative. I pass that point. I start going slightly uphill again. So my derivative is slightly positive and so forth. So at every single point, my slope that I'm running is slightly different than another point, and that's what the derivative is all about. It's about measuring the exact slope at any particular point. In the case of the thermometer, the function is the temperature recording with respect to time. So the temperature starts off lower, and then as we brought it outside and put it in the sun, the temperature reading on the thermometer went up. So the derivative would be the rate of change of temperature with respect to time. So when it first came out, it probably started to increase in temperature more rapidly, and so the derivative would be a higher value when we first brought the thermometer outside, and then after it had acclimated a bit to outside, then the rate of change of temperature started to taper off until it finally settled on 100 degrees. And at that point, the derivative would be zero because there is no more change. So there's not a rate of change. The rate of change is actually 0 degrees per minute. If you made a function that tracked the size of the pumpkin, so say the diameter of the pumpkin versus time, so you were measuring it as days went by, and the pumpkin starts off very small. The next couple days, the diameter is a little bit bigger. The next couple days, the diameter is even bigger. The derivative would be the rate at which the diameter is increasing per day. So it would be inches per day if you were measuring the diameter of the pumpkin in inches. If a hummingbird is flying away from a hummingbird feeder, then the function is position from the feeder with respect to time. So it might be measured in feet from the feeder. As he's flying away, the derivative of that function is his speed in feet per second. A car moving, the function is its position with respect to time. The derivative is its rate of change of position with respect to time, otherwise known as velocity, or speed if the velocity is always positive. Speed's velocity taken to be a positive number. So the units would be miles per hour or feet per second, some unit of distance per unit of time. And the squirrel's industriously chewing a pecan. And some of the derivatives that could be brought about from that situation would be the rate of change of volume of the pecan as the squirrel consumes it. So as time goes on, the volume of the pecan is decreasing. So the derivative would be the rate of change of cubic centimeters of pecan to time in seconds. Another function involved in this situation is the volume of pecan remaining as the squirrel rotates the pecan. The derivative of such a function would measure the rate of change of volume per degree of rotation. if the squirrel dropped the pecan, then the velocity would be the derivative. It would be the rate of change of height of the pecan with respect to time. So it would be the velocity as the pecan fell and headed toward the ground.